Fine. So let's configure this customer Microsoft Neox site on R1. So for that, first of all, I have to create VRF, right? And it is going to be same as previous class. Everything like all the configuration will be same as same as the previous class, right? And here in place of OSPF, I'll be using BGP, right? BGP 65500 here, so that it will be BGP peering, and here OSPF will remain there, right? Yes, you have to remain there, will remain there. And this time I'm not going to use same prefixes for these two customers, right? I'll be using different prefixes for these two customers, right? Because it is not always mandatory that customers will be using same prefixes, right? In some cases they will be using some different prefixes too, right? So this time I'll be taking an example of these customers in that way, so that they will be having different prefixes like I have mentioned in this diagram. Like here, this Microsoft customer is using 10.1.1.0 to 10.1.5.0 in Neox site, right? Then Microsoft is again using some prefixes at Gurgaon site, and these prefixes are starting from 10.1.6.0 and going up to 10.1.10.0/24. Similarly, it is happening with Yahoo and Yahoo London site, as well as along with that with Paris site, right? So that's all about all these things. Let's start doing configuration in perspective of customer Microsoft. So on PE1, this is PE1, right? PE1, and I'll be creating first of all one VRF, IP VRF. Let's say its name is micro, right? I have to allocate RD 1:1. Then I have to allocate route target, and I have already discussed it with you that why all these things are necessary for us to define, right? So route target for exporting, right, I'll be using 1:2, and then route target for import we can use 2:1, right? So from far end we will be exporting them with 2:1, right? Fine. Then after doing this, between edge routers you have to define, you have to configure VPN v4 neighborship, right? Between PE to PE you must configure VPN v4 neighborship. But I want to tell you now that in some cases, like for an example, you are having so many routers, right? Like this is router 1, this is router 2, and this is router 3, and this is router 4, router 5, router 6, you understand, router 7, and all of them are working as P router, provider edge, right? And all of them are connected like with R10, with R11. I mean, like they are connected in this manner. This is the core of the ISP, right? In this way they are interconnected, right? Now the problem is, like in case like for an example, customer is connected with this P router, and another side of that of the same customer is connected via this R3, right? This another P router. Fine. Now I said that P and P must have VPN v4 neighborship, right? Now you see that you cannot examine that, okay, this customer is going to be connected on this router 1, then this customer will be taking another MPLS connection via P router R5. No, you can't examine that, right? Customer can have their own site anywhere all around the world, right? And they can ask you for MPLS connection anywhere in this universe, right? So you cannot pre-examine that, okay, this providerized router will be having neighborship with this provider as, and along with that, let's say that, okay, you know that you can configure fully meshed VPN v4 neighborship, right? So in this case, all of the P routers can have fully meshed VPN v4 neighborship with them, right? Okay. Now the problem is, if you are going to configure fully meshed VPN v4 neighborship, then it will be really overhead, right? A big overhead for network designer, right? So to solve this problem, what can we do? We can take dedicated 2 devices, and those 2 devices will be should be reachable to all P routers, right, with redundant links. Fine. And then what can we do? We can configure like VPN v4 neighborship between those routers and P routers and those, you see, and along with this as well. All P routers, I mean, I'll be taking 2 routers in central. Make sure that those 2 routers are having reachability with all P routers, and then form VPN v4 neighborship between PE and those two routers. You understand? And configure them as route reflector. That's it. Configure them as route reflector. You will not require to form fully matched VPN v4 neighborship. You understand? So basically, in this way, we configure MPLS in the core of the service providers. So it is not necessary all the time that okay, all PE routers will be having VPN v4 neighborship with each other. No, it's not. You can have that thing in a small network, but where you are having like 50 of devices, you understand, like 50 of PE routers, then you can't do that. You can't form VPN v4 neighborship in fully matched way. And to solve that, we are having this concept of route reflector. Understood? So today I'm gonna to form VPN v4 neighborship like in between P1 and P router, and then further P router and P2. I will not be having direct VPN v4 neighborship between P1 and P2, and then you will see that we will require to configure this P router as a route reflector. Without configuring this router as a route reflector, your routes will not be advertised in between P1 and P2. Understood? So this time I'm gonna to do that thing over here. Like I will start it from here. Router BCP 100. As you know that in core we are using BCP 100, right? And here we are having only 3 routers, but you could have like 50 of routers, right? You could have 50 of devices, but either ISIS or OSP will be running in the background, so that all of them will be having reachability with each other, right? So router BCP 100, we can say that router BCP router ID is going to be 1111, and then I can say no BCP default IP v4 unicast. You understand? And then I can say that my neighbor is 22222 and remote AS is going to be 100, then neighbor 2222 and update source is going to be loopback 1. Any problem? Then address family VPN v4, right? And then we can say neighbor 2.2.2 and then just to activate it, nothing else. Similarly, move on R2 now. Say router BCP 100 and then say BCP router ID is going to be 22222, and then we can say what? No BCP default IP v4 unicast, right? And then neighbor neighbor and then address family VPN neighbor 3. So globally I am not running any BGP between R1 and R2 because I didn't configure neighborship for the global process, right? On R3 router BCP router ID is going to be no BCP sorry IPv4 neighbor Understood? Fine, neighborship must come up. Yes, neighborship has come up. You see between P1 and R2, and you can't see these neighborship in this manner, no? Because this is VPN v4 neighborship, right? So you have to mention that should be BGP VPN v4 all summary. Then only it can show you that okay, it is having neighborship with 2222, right? Fine. And now we have to configure like this fast Ethernet 0x0 that is going towards New York side, right? So I will be saying IPVRF forwarding, that is the member of VRF micro, right? And then IP address is going to be now 192.168.255.255.252/30, right? Say no shutdown. Any problem? Tell me. What? Fine. Then let's move on. Microsoft Customer Edge 1, and let's configure it as well. Fast Ethernet 0x0, that is going to be 192.168.1.1 on slash 30 itself. Loop back 10.1.1, loop back to 3, 4, 5, 6. Any problem? So now here there is no need to configure anything related to MPLS, right? Because it's a simple customer. So router RIP, not of summary, version 2, network, fine. All of the networks will be advertised into RIP now. Similarly, I'll move on P1. Here you have to configure this RIP for VRF micro. So you have to say router RIP. This is the global process of RIP. But within this global process, you have to configure sub process, right? So address family, IPv4, VRF, that name is micro. Now define your version to not of summary, network 192.168.1.0. Any problem? Now it must start receiving prefixes with the help of RIP now, right? So IP route VRF, that is what? Micro. Let's move back again on P1. Yes, it has received, right? All of the prefixes coming via RIP. Now we have to take them into BGP, into VPN, right? From VRF into VPN. Right now you do not have that, right? Into VPN. So MPLS forwarding table, you can see that there is no VPN label or generated by BGP for those prefixes, because still prefixes haven't entered into VPN. So now you need to take them from VRF into VPN. If you were running BGP in between P and C, then of course they will go automatically from VRF into VPN. You will not require to perform redistribution, but this time you are receiving all these prefixes in this VRF with the help of RIP, and of course prefixes can't move from RIP into BGP automatically. I mean, without redistribution it is not possible. Now do one thing, exclude that prefix which is running in between P and C, which is 192.168.1.0, right? So I'll be saying that access list 192.168.1.0 and then 0.0 dot, I think what, 3, is not it? Or you can make it 1.0 as well, right? Then access list 1 permit any, and then you can say route map redistribute, right? And then permit and match IP address what, 1, and then go to router BGP 100 address family IP v4, right? VRF, that's name is what, micro. Go to address family. I mean, now we are inside BGP, right? You have to say redistribute what, RIP route map, that's name was red, and that's fine. And now you must be able to see them within the BGP table, VPN v4 table, right? To see that, so IP BGP VPN v4 VRF, that's name is what, micro, enter. So run pipe section router BGP. Let me show you the configuration of BGP now on. So you see, right? This is there, this is there, and this is there. Fine. Let me show you. Show IP BGP VPN v4 all, enter. So you can see that these prefixes have entered now, right, into its BGP table, right? Any problem? Now you see that these prefixes are available into the VPN v4 table. Now it must advertise them towards its neighbor. Tell me. Yes, R2, and then R2 must give them to R3. So let's move on R3. Let's create this VRF, IP VRF. As I said that it is not always mandatory to take your VRF name as same. It's not mandatory. RD value, right? RD. It is not mandatory to take it same, but it should be same, right? Then route target. For importing, I'll be using 1:2, right? Because I have to import them, because from there I exported them with 1:2. And then from here I'll be exporting prefixes with 2:1, and then we don't need to do anything else, right? Because it will create address family for this VRF automatically. I mean, I'm talking about BGP. Show run pipe section router BGP. You will see that BGP will generate address family for this VRF automatically, or you can say dynamically. Yes, it has. So now show IP BGP VPN v4 all enter. So it is not receiving. It does not have anything in its BGP table. So what's the reason behind it? What? Exactly, route reflector. This time you see that R2 is for R2, both of them are VPN v4 IBGP neighbor, right? VPN v4 IBGP. So if R2 is receiving from R1, it won't give it to R3. So you will never ever receive them onto R3, right? Never ever. Even any update will not go there, right? Even you can look at there on R3, and let me show you debug BGP VPN v4 unicast all or what's that updates, right? And then let me do one thing. From P1 I'll say clear. Even I will do debugging on R2 as well. Debug BGP VPN v4 unicast updates, right? And then from P I will say clear BGP VPN v4 unicast star out. You understand? And now you see that it is receiving them but denied due to external community not supported. You understand? And you see on R3 it is not receiving them at all. R3 is not getting them. I mean, this is P2, right? First P2. So it is not receiving them. So how can we solve this problem? By configuring this R2 as a route reflector. So now we have two options. Either create VRF onto R2 as well, and it is not always possible to create all the VRF on all devices, right? It is not possible, right? So here now you have two options: either create VRF on R2 or configure it as a route reflector, right? So I'll be doing one thing. I'll say router BGP that is running 100 address family VPN v4, right? And then I'll be saying 1111 is what route reflector client. Similarly 33 is what route reflector client. That's fine. Now you have configured this device as VPN v4 route reflector, right? So once you will configure it as a VPN v4 route reflector, now you must be able to see all of the prefixes available on P2 as well, right? So this time you must be able to see them. So IP BGP VPN v4 all enter. You see a PE2 has also received all the prefixes coming from PE1. Understood? So in this way we can configure VPN v4 route reflector in BGP, or you can say it will be required in case of MPLS.
So that message was extended community
Is not supported, yeah,
because route target
was not configured over there.
On that.
But this time, because we have configured that as a route reflector, so it will work. Right, so this time P2 has also received all the prefixes. Now we have to configure EIGRP, right? We have to configure EIGRP in between PE2 and customer edge, Microsoft customer edge Gurgaon site, right? So for doing that, I'll be doing something like F0 by 0 IPVRF forwarding. That is what my IP address is what 2.2, right? Microsoft CE1. I think it was on /24, right? Sorry. Of what is this? This is Microsoft CE2, and it is going to have 2 dot. Router EICRP, let's say 100, not assembly network, right? This is the configuration of customized. For provider edge, can take anyone, anything, then address family IP, v4, VRF, that is mic. Now say autonomous system is what? Actual one, and then auto summary network. Any problem? It must form neighborship now. So IP ICRP, VRF, mic, neighbor. It will show you now, right? And then show IP route, VRF, mic. It is having all the prefixes, right? Now prefixes can move from BCP into EICRP automatically, right? So you have to perform redistribution. So you have to say router EICRP. That globally we were running 1, then address only IPv4 VRF, that is mic, and then you have to say redistribute BCP 100 matrix 1544 0255 1 and 1500. Microsoft CE2. So you see, this is the thing actually. You have received them, right? Similarly, now you have to take these EICRP prefixes into BCP, right? Because by default, again, prefixes won't go from EICRP into BCP. For that, on R3 router BCP, that is what? 100 address family IPv4 VRF, name is say redistribute. That's fine. So IP BCP VPN v4 all, enter. So you have performed redistribution now. You see, right? For all these prefixes, now you must get that onto PE1. So IP BCP VPN v4 all, enter. You have received them. You see, right? And now show IP route VRF micro. So it has received all the prefixes like 6, 7, 8, 9, 10 via BGP. But again, they won't go from into RIP. So you have to perform redistribution on PE1 itself. So say router RIP address family IPv4 VRF, that was micro. Say redistribute BGP 100 matrix, let's say 1 or 3 or 5, whatever you want to take, right? Because in RIP its matrix is going to be now hop count. But do not configure it 16 or 15, right? On Microsoft CE1 now, you must be able to see all of them. Yes, all the prefixes are available, right? Now, from CE1, try to ping with 10.1.6.1. Source is loopback 1. Repeat And on R2 you don't have anything. There is no VRF, nothing. It does not have any route in its routing table.
So we have made this
R3 as route reflector.
R2 as a route reflector for
Yes.
VPN.
V4, yes, for VPN V4 neighbors. I was having this diagram.
Okay.
So many P routers are there, so many. It is not going to be possible to form fully meshed VPN V4 neighborship between P routers, right? So what do? We take two routers, separate routers, configured anywhere in the network, right? But must be reachable from all P routers. All P routers will form neighborship with both of them. We will configure them as a route reflector. Even these route reflectors can be out from your MPLS domain itself, but must be in same AS. In case if MPLS is not running on these two route reflectors, it will work fine.
If there is no LDP, you want to say.
Exactly. If there is no LDP running on these route reflectors, then also they will work fine. But make sure that these route reflectors are not coming on the way, on the path to reach from one PE to another PE. I mean, these must not be your transit devices.
So we will do the label swapping.
Exactly. I mean, these route reflectors will not perform label swapping because they are not transit devices. I mean, you can put them as promiscuous, somewhere in the edge of the network.
What is the BGP configuration of R2?
And you know why RD is required? I don't have any VRF over here, right? But it will be having prefixes coming from different customers, and those different customers can use same prefixes. Then how will it be possible for it to separate them? That is what RD. So prefixes are coming with RD value. It's not it. It is having this prefix.
Did we configure RD on this?
No, not on R2.
Not on R2. Right?
Yeah, we configured it on R1 and R3.
Right.
That's why I said that it does not have locally significant. Goes along with BGP updates through VPN.
So R2 has prefixes, but it's within the RD.
Within the VPN, you can say.
Within
Yes.
the VPN.
But it haven't installed them into routing table, right?
Right.
Type it out. Nothing like that. MPLS forwarding table, nothing.
So considering an example where RR is separate than the P.
Let me. This is physical topology, right? That's what I'm gonna do. Draw here. This is physical topology R2, R3, R4, R5, right? R6, R7. This is physical topology. Now you configured this R1. This is going towards customer. This towards customer, customers. These all 5 routers are P routers. This is P router. This is P router. This is also P router. This is also P router. Now these P routers are not going to form neighborship with each other, right? What will I do? I'll form neighborship in this way. indirect neighborship, right? In this way.
That's the IBGP neighborhood.
VPN v4 neighborship.
VPN.
This is VPN v4 neighborship, right? Right? And now, because you have to configure them as a route reflector, right? VPN v4 route reflector. I'm taking 2 route reflector just because of redundancy purpose, right? And now you don't need to configure LDP over there, right? At all, because they are not transit devices. If you look at the physical topology, traffic, if traffic is, let's say that there is a customer C router behind R1 and there is a C router, traffic will go in this manner or in this manner, right? So you just need to implement LDP in between R1, R2, R3, R1, R5 and R4 and R3, right? You don't need to configure LDP in between R2 and R6 and R3 and R7, because those 2 routers are completely separate devices now, and traffic will never go through that. Only updates, BGP updates are going through them, not data.
So LDP we define on the interface.
Not, you don't need to define LDP on R6 and R7.
No, that's fine.
Yes, of course, we configure LDP on
the
interface basis,
MPLSIT.
of course.
Right. So it would be like, for an example, R1 and R5 as LDP neighbors.
Of course, we have to configure LDP between them.
Right.
R1, R5, R2, R2 and R5, R2 and R3, R4 and R5, R3 and R4. Everywhere we have to configure LDP, except R6 and R7. Because you can look at here, if traffic is going from one customer to another customer, they will never, the traffic will never require to traverse R6 and R7. So even if you are not running LDP over there, that's fine. Because those devices are just used to exchange BGP updates on, not for data. Because you know very well, next hop will all be PE routers, right? PE routers IP address. Next hop will always be PE routers next hop address. So whenever traffic will go from 111 to 3333, it will go directly. Whenever traffic will come back from 333 to 111, it will come directly in this way. It's not it. And OSPF is already running. ISIS is already running in the background.
So we have P routers also in MPLSpart, only P.
Only P. Yeah, it depends on designing.
What's the use of that if we have this kind of topology? We don't need P routers.
Of course.
Or
Now we don't have any requirement.
Right.
But in case if you are having like only OSPF was running on these 2 routers, right? Only OSPF, then you can call them as P router, right? Or ISIS.
And in that case, PE would form LDP neighborship with P.
With P routers as well. With P routers.
PE or P? P only.
P to P.
P to P. And there will be no direct PE to P.
Of course, in actual you will never find that there is a VPN v4 neighborship between PE to PE.
Right.
Never ever.
And it will be between PE to P.
Of course.
And then route reflectors would be exchanging routes
Only
between P to
P
P.
to P. Exactly. Exactly.
Right.
Exactly.
That's
That's what I said, that now after designing this network, now if any customer is coming and connected on R1, fine, on this P, and now they took another connection that is terminated on R4, right? Over here. No problem. Create VRF. That's it. That's what you need to do for this customer. Once you have designed all the network, you just need to create now VRF and you just need to perform redistribution. That's it.
Right.
You don't need to define VPN v4 neighborship and all these things. You don't need to be worried that okay, whether this P router is having neighborship with another P router R1. No, you don't need to worry about that, because they are already having neighborship with route reflectors. Now let's configure this MPLS for this customer, that is Yahoo. So I'm on P1, and on P1 I'm going to create another VRF, IP VRF. Sorry. Yeah. 2:2 route target. For exporting, I'll be using 3:4. For importing, I'll be using 4:2. Right. Go to F0/1 IP VRF forwarding Yahoo. IP address is going to be now 3 dot. Understood? That's what I did on PE1. Let's have the console of Yahoo CE1 as well. Right. Then router BGP, that is running 65500, right? Neighbor is going to be now 3 dot. 2 remote S is going to be 100, right? And then say network dot 20.1.0 mask, right? We need to move on PE1 now. Once again, router BGP 100, address from the IPv4, right? VRF is what? Yeah, neighbor is going to be now 3 dot. Remote AS is neighbor chip must come up.
If we mention here incorrect VRF,
It won't accept it.
So VRF is between P to C to match.
You see, no. You see. The question was that if there is no VRF available, which we are calling within the address family, will it work? So it will not work.
no, if we change the character,
Of course, no.
it will not work.
Your VRF name must be same, that you created within the address family.
Between P to C is not fine, or within the router?
No, within
P
the
to C is not required.
Right.
On C, there is no need to configure the
So on P, we have done this configuration now. So IP, even BGP peering has also came up with the customer, right? Now you see show IP BGP VPN or show IP route VRF Yahoo. You see. From its neighbor 3.1. Show IP BGP VPN v4 VRF Yahoo. That's fine. Or if you say all, show you for all VRF. I'll move on now. R2. I'll show you show IP BGP VPN v4 all. It's not it. It's R2. finally on R3. R3 is not going to accept them. That is why if you say all VPN v for all, you won't get them. You haven't created any VRF, and also it is not working as a router platform. So IP VRF, its name is Yahoo RD 2:2 route target. For exporting, I'll be using 4:3 route target. For importing, I'll be using 3:4. That's what we are required to do over here, right? On this PE2, right? Move on PE2 once again, and on this PE2 now go to F0 by 1 IP VRF forwarding. That is what Yahoo IP address is going to be now 4.2, right? Now shut down. Now say show IP route VRF. That is what Yahoo. It will take some time, right? It converts slowly. Till that, what can we do? We can configure OSPF in between this P and C, right? So let's have the console of C, Yahoo CE2. On its F0 by 0 is going to have an IP address 192.168. That is what 4.1 on /24. Then we can have some loopbacks over here. 192 sorry, that is 20 6.1. Router OSPF 100, right? And now we can allocate any route, right? It will pick it automatically, right? We can do one thing, router ID 100.100.100. Let's say it is 4, right? Network, that is going to be area. On to loopback interface, IP OSPF, network type 4, loopback 2. You know very well that why I'm doing it, right? Otherwise, you know, OSP will advertise loopbacks on /32. Let's move on now. P2. On P2, say router OSPF 100, and then VRF name is what? Yahoo, right? Router ID is 100.100.100. Let's say it is 3, right? And network is going to be 168.4.0, and area is going to be 1. Now neighborship must come up, right? Try to escape neighbor. Check it out. It is in two-way state because it has to perform an election of DR and VDR, right? Or you do one thing. You could do one thing. F0 by 1 IP OSPF network type is what? 0.2 point. Similarly, I'll move on C2, and on C2, yes, this is C2 interface F0 by 0 IP OSPF network type is what? 0.2 point. Now it will form neighborship immediately, right? So that's fine. This is P2, so IP OSPF neighbor, and this is C, must have neighbors now without DR and BDR, right? But you know very well that prefixes can move from BGP into OSPF and vice versa. Prefixes can also not move from OSPF into BGP as well, right? So to do that, on P2, we can perform redistribution from BGP into OSPF, right? So let's do that. So router OSPF 100, and this is VRF what? Yahoo, say redistribute BGP 100, right? And then subnets, and then metric type, let's say 1 tag, let's say it is 100, whatever you want, right? You can do that. Then just come outside. Now you must be able to get all of them onto Yahoo CE2. So let's move on Yahoo CE2, and here we must be able to see all of them. Yes, all of them are coming over here, right? And similarly, you need to take prefixes from OSPF into BGP. So you have to redistribute this OSPF into BGP onto P2 itself, right? So you say router BGP 100 address from the IPv4, and that is what VRF. Its name is what? Yahoo. Say redistribute OSPF 100, and its name was VRF name was Yahoo, and that's fine. That's what you need to do, right? And one more thing, that whenever you redistribute OSPF back into any other routing protocol, by default it does not, I think it does not include redistributed prefixes, right? So at that moment you have to say, sorry, match internal, match external type 1, external type 2, or an SSA. I mean, you have to specify that, okay, I want to redistribute external prefixes as well of OSPF into BGP. Like OSPF was already having some external prefixes in its routing table, right? So in that way,
This is for only external prefix.
yes, right? So this time you have redistributed this OSPF back into BGP. Now you must be able to see all of them on PE1, that is R1, right? So now you can say show IP BGP, pip in V4, all yes, 2:2. Okay, not yet. Okay, first of all, let's check on P2 itself. So IP BGP, VP and V4, all, enter. Yes, redistribution is done, right? 6, 7, 8, 9, 10. You must be able to see them on PE1 as well.
टारगेट शायद नंबर गलत हो गया, 4:2 हो गया था।
Yes. So IPVRF detail for Yahoo. Yes, that is 4:2. IPVRF, that is what? Yahoo, right? Route target for export is what? 4:3, right? It's not 4:2, so remove it. So IPVRF detail, right? So this time we must be able to see them onto PE1. From PE2, say clear BGP, VPN, V4, unicast, star, out. Right? And now, because they are received from BGP, they will move into BGP automatically. So this time you are not required to perform redistribution on PE1, and you must be able to see them onto Yahoo CE1 automatically. Show IP BGP, first of all in BGP table, and then after, of course, all of them are there, right? And then in routing table as well. And then you can also try to ping with 20.1.6.1. Source is loopback 1. Repeat. If you do not put your source as loopback, then you won't be able to ping with that, because you do not have reverse path. We didn't advertise that lane, I mean that prefix that is running in between PE1 and Yahoo CE, right? So this is the way to configure MPLS. Okay, in previous class we configured the same thing, right? Although we were having same prefixes for both customers, right? But this time we are having different prefixes. Now what I want, the requirement is Gurgaon site of Microsoft wants to communicate with the users of London site in Yahoo. Now users from different organizations wants to communicate with each other.
Communication between different URLs.
Yes. That is also called route leaking. So we want all the prefixes which are in Microsoft Gurgaon site in Yahoo London site, right? So on PE2 we are exporting prefixes of customer Microsoft with export RT. Let me check it out on P2. Show IPVRF detail. Look at Microsoft. For exporting we are using here on PE1. Show IPVRF detail. For Yahoo we are importing them with 4:3 only. Now what can we do? IPVRF route target for import, that is 2:1. So IPVRF now in this VRF you must be able to see all the prefixes, right? You see, show IP BGP VPN V4 all. Check it out. Wait. Yes, it's done. For Yahoo 10 6 7 8 9 10, right? 6 7 8 9 10. Check it out. It's not it. So now show IP route VRF Yahoo. Check it out. And now all of them must be present on CE1, Yahoo CE1. Check it out. All the 10 prefixes, 6 7 8 9 10 only, right? So yes, it's there. Similarly, we want these 20 prefixes of London site in Microsoft Gurgaon site. So you are exporting from here, right? Check that RT value. So IPVRF data. In Yahoo, we are exporting them with 3:4. Move on P2. Inside Microsoft, we are importing them with 1:2 only. So we have to import them with 3:4 as well. So now IPVRF Yahoo. Now target for importing 3:2. Now show IP BGP VPN V4 all. Your changes haven't taken place yet, but they will take place. It was not changed, right? IPVRF mic route target for import is what? 3:4, right? Let's check. This time it has taken place, right? So now show IP BGP VPN V4 all. Check it out. Clear. BGP VPN V4 unicast star. What is happening? Yes, changes have taken place. When you can look at this, show IP route VRF is what? Mic 20 prefixes, right? And then you can move on Microsoft CE2 all 20 prefixes, right? 1 2 3 4 5. Then move on Yahoo CE1, and from here let's try to communicate with 10.1.6 6.1 when source is root f1, repeat. Now the end users of Yahoo and Microsoft can communicate with each other. That's what you need to do. Everything else will remain same.
Considering this example, RD is significant in core and RTs are on the edge primarily because we didn't make any change on the RT value. The provider had just mentioned the same RT value on the same VRM. But in core, it is like
And
RD
in
is-
very simple manner, you can say that RD is just used to distinguish prefixes, right, from each other.
in the core.
And yes, in the core on edge as well, on edge devices as well, on P routers as well, because you are having two different VRFs, you are having same prefixes over there, right?
Right.
So RD will be used to distinguish them. Second, RT is just used to define that which VRF can accept which prefixes.
Right.
That's what RT means, route target. Right, so this is the way to perform route leak. Even you could perform leaking in between New York and Yahoo as well, New York and London side, same with same manner, same thing. Export, import, export, import.
Within that P1.
Yeah, of course.
In
That's-
import and export, can we use the route filter?
Yes, of course. Like this time, what is happening that we have import all the prefixes of 20s prefixes, right? Sorry, 10s prefixes. We wanted to receive only 6 and 7, right? In Yahoo side, right? So we wanted to receive 6 and 7 only, or you can say we don't want to receive 7, 8, 9. Sorry, 8, 9, 10. So what can we do on PE1? Access list 10 deny 10.1.6 dot, sorry, not 6, is 8.0, then 9.0, then 10.0, and then access list 10 permit any. All others are permitted, right? Now create one route map, import map, right? Or import underscore map, right? Permit 10. Match IP address is what? ACL 10. Now go to IP VRF, that's name was Yahoo, right? And now say import map, and then import map means route map name, that is what? Import underscore map. Now it will import only those prefixes which are allowed in import map, and in similar way you can configure export map. If you configure export map, only those prefixes will be exported which are permitted in your route map, in your export map. You understand? So this is the way to use import map and export map. Now let me show you IP VRF detail. Even it will show you that in VRF Yahoo you have configured a import route map, but in VRF micro there is nothing like import map or export map, right? So this is the way to configure it now. I hope you people have understood it now, right? So this is the way to configure import map and export map. And now you can look at IP route VRF, and that is what Yahoo. Check it out. It's not it only 6 and 7 are missing. In similar manner, in similar fashion, you can implement export map. But remember that export map will be working for those prefixes which are exported from VRF into VPN. And this time import map will work for those prefixes which were imported, yes, for receiving prefixes, right? Which you are receiving from VPN into VRF.
Okay, if we have configured R2 as a root reflector, so is there any way, means any command to check the customer prefix on R2?
Yes, there is. On R2, users need to do only. Users need to configure one command. So IP BCP VPN V for all. That's it.
So when we create it as a root reflector, then we are able to check.
Of course, exactly. You can check your customer prefixes, but remember that it is not going to install them in its routing table, right? You want people to get them in its routing table because there is no global process.
VRF.
Yeah, there is no VRF, there is no global process running of BCP.
And then route reflector config is done under VPN v4 in that
Yes,
R2?
yes, of course. You check it out. But extended community, right? That's really important.
Right.
We have configured it.
No, it will come up automatically. But if someone have removed it, right, in T-shoot, then you have to implement this command.
Otherwise it will drop RT value.
Yes, and if it drops RT value, then those prefixes will never be delivered onto another site.
If we remove the activate command from VPN v4, what will happen?
Neighborship won't come up.
VPN v4 never should.
Yes. Because in BGP, as you know, that except default address family, it is mandatory to activate your neighbor for all address families, right? Hopefully, you people have understood it now, right? Import map, export map, and all these things. This is called route leaking, and in this way you will be implementing MPLS. Apart from that, now in OSPF we have some different things in MPLS to learn. Like the behavior of OSPF is a bit different actually if you compare it with some other routing protocols like EICRP, ISIS. If you are implementing OSPF along with MPLS, right? So this time what will I do? I'm running here OSPF 100 area 1. Similarly, I'll be running OSPF 100 area 1. Right? I'll remove BGP and I'll be configuring OSPF 1. Let me move on. Yahoo C1. I'll say no. BGP. Similarly, B1 so BGP 100 address only IPv4 VRF Yahoo no network. Right, I've removed it now. Instead of using BGP in between P and C, this time I'm going to use OSPF1. Same process and same area, right? Yahoo C1 router OSPF 100, right? Router ID is 100.100.100.1. You understand? And then network in area is going to be 1. Interface loopback 1. IPOSPF network type is what? Loopback 2, 3, 4, 5. Any problem? Fine. So now let's implement OSPF on P1 as well. Router OSPF 100 and VRF is going to be Yahoo router ID is going to be now 100.100.100.2, right? And the network 168.3.2, and area is going to be 1. Any problem? And then you have to perform redistribution this time, right? You have to perform redistribution, right? And one more thing that I would like to do over here, show run type section IPVRF Yahoo. I'm going to remove it 2:1, right? And also I'm removing this. So run pipe section. I mean, I've just stopped route leaking now, right? Route leaking is not there. Fine. Then after, you have to perform redistribution from OSPF into BGP and back from BGP into OSPF. So router BGP is 100, address only IPv4, VRF, that is what? Yahoo. So redistribute OSPF 100 and VRF is what? Yahoo, right? And then similarly go to router OSPF 100, VRF is what? Yahoo, and then say redistribute BGP, right? 100, right? Subnets, matrix type is what? 1. You understand? And then after I have to define my tag value. Let's say that this is what? 200. We must be able to see all of them on Yahoo CE1. Yes, all of them are there. 6, 7, 8, 9, 10, right? Similarly, on Yahoo CE2, all the prefixes must be there. Yes, all of them are there. 1, 2, 3, 4, 5. You understand? 1, 2, 3, 4, 5. But this is a miracle, right? I performed redistribution, but these prefixes are coming as inter area. Is not it? I performed redistribution from BGP into OSPF, but prefixes were coming as inter area. Why? See, show IP OSP border route who is working as an ABR as well as ASBR is 2, which means, see, I configured. Let me tell you that I configured router ID here 100.100.100.100.1. Here I configured on P1 100.100.100.2, and here I configured its router ID as 100.100.100.3, and then finally here I configured router ID 100.100.100.4. So this time you can see that on Yahoo CE1, this 100.100.100.2 is working as an ABR as well as ASBR. Done. Fine. Then on Yahoo CE1, prefixes are coming as inter area prefixes. You see, and you can look at IPOC database table. You won't get any type 5 LSA. You will get only and only type 3 LSA, summary LSAs. You understand? Advertising route is APR. Fine. Why? What? Yes. On PE1, you see show IP OSPF. I'm just running this command, right? OSPF 100. Because I'm talking about OSPF 100. What is it showing you? So if you are redistributing BGP, especially inside the VRF, right, into OSPF, it will always come to know that okay, it is connected with super backbone, and super backbone, which means that it will treat as area 0. It will treat it as area 0 now, and you can see that it is working as an ABR as well as ASBR, redistributing routes from this. right? So super backbone, MPLS core will always be known as super backbone for OSPF. I mean, MPLS domain will always be called as super backbone for OSPF, right? So it will treat it as ABR, as an ABR as well as ASPR. And why is it treating itself as an ABR? Because it is
Super backbone.
it is concluding that it is connected with super backbone, which is area 0, right? That is why it is announcing itself as an ABR. Similarly here, it is an ABR. Fine. That's fine. That okay, they are working as an ABR because they are connected with super backbone. But why prefixes are coming as some DLSA? However, we performed ray distribution. So after ray distribution, why prefixes are not going in the form of type 5 LSA? Why are they going in the form of type 3 LSA? Process ID, exactly. If you are using same process ID on both P routers for the customers, right, then they will always go as type 3 LSA. You know why? There is a term, OSPF that's called domain ID. There's a terminology in OSPF that's called domain ID, right? So you can look at P1, that what is the domain ID of it. You see that this is the domain ID, right? This is, right? Similarly, you can look at PE2 and you can see show IP OSPF 100. So it must be same now, right? So it is same. Yes, it is same. And if domain IDs on both P routers are same, then they will always go in the form of type 3 LSA, summary LSAs. And this domain ID goes along with BGP updates in the form of extended community. Domain ID will also go along with BGP update in the form of extended. That is why another P router will come to know that okay, it is having same domain ID, right? So for that purpose, when you redistribute OSPF into BGP, then the domain ID of OSPF will be included in the BGP updates as extended community. Let me show you. You are on PE2, right? Show IP, you see, its on domain ID is this, right? Now you can look at show IP BGP, VPN, V4. VRF is what? Yahoo. You understand? VRF is Yahoo. And the prefix was 20.1.0. Let me show you. This is the domain ID that is coming in BGP updates, right? This is the domain ID of remote P router, right? And if you look at 6.0, that is its own prefix, right? That is its own prefix, and its domain ID, that is what? Same. That is why ray distributed prefixes are going in the form of summary LSA, right? If you change their domain ID, like for an example, I'm going to change this domain ID manually. See, how can you change domain ID? There are two ways to change domain IDs. One, use different process IDs on both P routers. Use different process IDs on both P routers so that your domain ID will get changed. Another method is to change domain ID manually. You can also allocate your domain ID to OSPF manually. Like I'm going to do it now. I'll be moving on P2 now, and I'll say router OSPF 100. VRF is what? Yahoo, right? Domain ID. In the format of IPv4, 1:1:1:1:1. Fine. Now on Yahoo C2, prefixes must come metric type 1 and tag value and everything, right? So IP OSPF database. I'm on Yahoo C2, right? If you move on Yahoo C1, type 5 LSA. Because this time they are having different domain IDs. Even you can look at P1 itself. This is for 20.1.0 and this is for 6.0. Now both domain IDs must be different. See, now it is different.
अच्छा इसमें हमने redistribute जब किया था type 1 में किया था तो इसलिए वो even पे आ रहा है.
Exactly. I specified that metric type 1, right? Tag 100, 200. So I hope you have understood the uses of domain ID now in OSPF, right? So if you are using same process ID on both ends, then by default their domain ID will also be same. But you can modify domain ID by changing their process ID, or you can modify domain ID statically as well. So this is the significance of domain ID in OSPF, right? Now in OSPF there can be a routing loop, right? Let me tell you how. There are certain situations in which routing loop can occur or routing loop can form. Fine. So I was just telling you, let's say this is P router P1 and this is P2, you understand? And this is customer edge 1 and this is what customer edge 2, and you are running OSPF here, you are running OSPF here. Then these customer edge routers are further connected with each other in this manner, right? So what will happen, let's say that this is P route, these are P routers, right? These are P routers. So SPF is running in between P and C. On P you perform redistribution, on P2 again you perform redistribution, right? Mutual redistribution from OSPF into BGP, BGP into OSPF, and prefix was coming from BGP into OSPF, redistributed, right? And again this redistributed prefix will get redistributed back into BGP, so that can form a routing loop. So to avoid that situation in OSPF there is a bit that's called down bit, that's called down bit. See, in case of external, see if prefixes are coming as external prefixes, you can look at their Yahoo C1, then there will not be any problem. Then there will not be any problem. You know why? Because external prefixes cannot be redistributed back into any other routing protocol by default, right? Unless you don't specify that, okay, match external as well, right? So there will not be any problem related to external prefixes. But in case if prefixes are coming in the form of inter-area prefixes, like previously they were coming, right? Like let me move on P2 once again. Route to SPF 100 VRF is what? Yahoo, right? Just do one thing, just remove this domain ID, right? And once again you will see that prefix will start to come as inter-area prefixes, right? So let me show you. Show IP route. Yes, okay, let's wait for a moment. Inter area, right? Similarly on Yahoo C1, still they are coming as a E1, but I mean later on it will be updated. And my god, inter area, right? Yahoo on both ends they are coming as inter area, and now there can be a routing loop because it can redistribute now inter area prefixes back into BGP, right? In this case now it is possible to form a routing loop, right? Because this time that feature of OSPF, that by default OSPF does not redistribute external prefixes into any other routing protocol, that will not work, because this time prefixes are not coming as external prefixes. Prefixes are coming in the form of inter-area prefixes. So for that purpose, again in MPLS we are having one solution for that. There is a show IP OSPF database. You see that there's some LSA, right? Show IP OSPF database summary, and you can open some LSA, and what is it saying? Downward bit is there. Down bit will be added whenever you will redistribute anything from MPLS into OSPF. If it is creating type 3 LSA, it will always specify down bit, downward bit, right? Down bit. And whenever you will redistribute OSPF back into BGP, it will always check that down bit. If any prefix is coming with down bit, it will not redistribute that prefix into BGP. So if prefix is getting entered into OSPF, then OSPF will try to redistribute back into BGP, but it will not be redistributed due to down bit. Hope you people have understood it. Any problem? So that is why this downward bit is there in type 3 LSS. So I hope if someone asks you that what is the meaning by down bit in OSPF, you can easily explain. This down bit will be in use in MPLS only, right? So this is the way. Fine. Everything is fine now in OSPF. But later on we decided to have a backdoor link. Later on we decided to have a backdoor link, like you connected this F0 by 1 directly with this F0 by 1. Right, this is the backdoor link now. And here let me tell you that I'll be using 192.168.100.1, and here I'll be using 100.2. Right, let me do that now on Yahoo C1. 100. This is what 1. IPOS network type is what, right? Then on Yahoo C2, neighborship will come up because they are in same area, right? They will form neighborship, and if customer as C1 forms neighborship with that, what is this? What? Okay, this is for 2, which means this one, right? Here DRBD relation is there, right? Fine. Now for customer S1, check its routing table. Which path is the best path to reach 678 via backdoor? 100.2. Just because of OSPF route preference, intra area will always preferred over inter area. Even if you put here like you are on C1, Yahoo C1, and if you go to F0 by 1, you said IPOSPF cost like 60,000, but still best path will be via backdoor link only. You see, 60,000, because you cannot manipulate this selection by manipulating their AD value or metric. Intra area will always preferred over inter area. However, these MPLS links are your primary links. This is primary, and this is also what? Primary. You understand? These are primary links, and they are primary links, and traffic should go by primary link only. And this backdoor link must be in use in case if primary link goes down. This is really expensive. How can we do that? Now we have 2 options. Either via backdoor link start receiving your prefixes as inter area prefixes, right? So that you via MPLS you are already receiving prefixes as inter area prefixes. Via backdoor also you will start receiving your prefixes as inter area, so that they can compare their cost. They can compare their metric, and then they can define their best path based on metric. Or you do one thing. Via MPLS, you do one thing, you configure your MPLS in that manner, in such manner, so that you will start receiving your prefixes as intra-area in the form of router LSA itself. I mean, you have to do any one of the thing, right? Now, it is not possible to receive prefixes as summary LSA, I mean in the form of summary LSA as inter-area via backdoor, because they are in same area, right? That's not possible. But for MPLS, we are having a feature that's called sham link. we can configure sham-link, and if you configure sham-link is something like virtual link. Do you remember that we were using virtual link to extend area 0? Here in our MPLS we can configure sham-link so that OSP will start receiving prefixes in the form of router LSA intra-area. So now after that you will see that Yahoo CE1 will start receiving prefixes as intra-area from both neighbors, and then after it can compare their metric, and it can decide or it can define its best path based on metric. So for that purpose we have to use now sham-link, right? So sham-link will always be configured in between PE router provider edge, and sham-link cannot be configured by the customer. Only provider will be responsible to configure sham-link, and you have to instruct your provider that okay, I want this actually, so please do this, right? So this time we are gonna to form sham-link in between PE1 and PE2, and you have to do that, right? So for that purpose, let me do one thing. I'll move on PE1. You understand? I'll move on PE1, and on PE1 I'll be creating one loopback 100, and IP address is going to be 100 100 100 100. This is the IP address, right? On /32 itself, IP VRF forwarding, that is what? Yahoo. Again allocate an IP address because it was removed now, right? And then advertise it into BGP. Advertised it into BGP. Router BGP, that was 100, address only IPv4 VRF, right? That was what? Yahoo. And then say network 100 100 100 100. Mask value is going to be now 255 255 255 255 255, right? Show IP BGP VPN v4 all, enter. Sorry. Show IP BGP VPN v4 VRF is what? Yahoo. Check it out. That 100 must be there. Yes, it is there on /30. Now it will advertise it towards P2, right? Of course it will go up to P2, right? So P2 must receive it. Yes. Let's move on P2 now. Show IP BGP VPN v4 VRF is what? Yeah. Check it out. That it must be there. Yeah. That is there. It is received from 111. And you see now show IP route VRF. Yeah. Check it out. 100 100 must be there. Yes. It is coming. Oh my God. It is coming as. What does it mean? Which means it is coming via OSPF. It is coming via OSP. You know why? Because if R1 is giving it to R2, R2 will give it to R3. Fine. And its AD value will be by default 200 because it is kind of IBGP neighbor, right? It is VPN v4 neighbor is in same AS, right? So its AD value will be 200. At same time, you are also redistributing this BGP into OSPF on PE1, right? So when you advertise that prefix into BGP, it will get redistributed into OSPF as well as E1, right? As E1, it will give it to Yahoo C1, C1 will give it to C2, C2 will give it to P2. And if it is learning that same prefix with the help of OSPF, its AD value is going to be as 110. So of course it will define its best path via OSPF itself. And we are going to configure sham-link over MPLS. So from here, make sure that PE2 is receiving this prefix via BGP only. You have to make sure it, right? So for that purpose, because we performed redistribution on PE1 from BGP into OSPF, we can exclude this prefix during redistribution. So you do one thing, move on, PE1, create one access list, 20, deny 100, 100, 100, 100, right? And then access list 20 permit any. Now do one thing, router OSPF 100 and VRF was what? Yahoo, right? You said redistribute BGP 100, right? Subnets. Metric type was 1, right? And tag was 200. Along with that, we can use route map, and its name was, oh my God, I didn't create, I think, any route map. Let's say I created route map name as test. So you say route map test permit 10 match IP address what 20. Now you must not get that 100 100 100 in the database of OSPF, right? So IP OSPF database, check it out. Process 100, it is still there. But now it is coming from 100 100 103, which is R3. So now that's fine. See, this time it is not redistributing. P1 is not redistributing this prefix into OSPF. This time who is receiving? Who is redistributing? This P2. You can look at this. See, is router ID is what? 100.100.100.3. If you look at P1, previously this type 5 LSA was redistributed by .2, which was P1, right? Oh my god, where is that? And this time it is redistributed by 3, right? So this time if you look at the P2, on P2 previously it was coming via OSPF, but this time it must come via BGP on P2, right? Because now we have excluded this prefix, I mean 100, 100, 100, 100 on P1 from redistributing BGP into OSPF. Similarly, I have to create one loopback on P2 as well. Interface loopback, let's say 200. IP address is going to be 200, 200, 200, 200. You understand? And then IP VRF forwarding is what? Yahoo, again allocate an IP address, right? Go to router BGP 100 address only IPv4. VRF is what? Yahoo, network is 200, 200. Mask is going to be, you understand? And once again what will happen, that it will also redistribute it into OSPF. So P1 will receive it via IBGP as well as OSPF. So P1 will start preferring for this 200, right? OSPF. That's wrong. So you do one thing, move on. P2 say access list 20 or 30, whatever it is, deny 200, permit. Route map is what? Match IP address. Sorry. Router. You said, right? At that moment you said subnets, metric type, tag, and then that is, after this P1 must start receiving this prefix via BGP. Yes, that's done, right? And now you just need to configure this command. Router OSPF 100 VRF is what? Yahoo, right? In it you have to say area 1, because on both ends area 1 is running, right? Area 1 sham link, and then IP address associated, right? It is what? Source address is what? 100, and then destination, right? That is. Similarly, you have to move on P2 router OSPF 100 and VRF Yahoo, right? Say area 1 sham link, source, destination, and now after configuring the sham link, now sham link must come up, right? So sham link will come up now. You see it has came up now, right? And then after you will see that this C1 will start receiving these prefixes as intra area from both neighbors, right? So now you can move on Yahoo C1. Swipe it out. Its best path is now to reach 20.1.67 is now via, and cost is 22, and it is via 3.2, and 3.2 is what? P1. So this time if you trace route and this is 20.1.6.1. check it out, it is going via MPLS, right? If you look at Yahoo C2 routing table, then still its best path is via, you see, tell me 100.1. You know why? Because we haven't modified its cost, right? So now you do one thing, go to F0x1, say IP OSPF cost is what? Make it 10,000, that 1,000 as well, right? It will work fine, right? So for Yahoo C2 as well, you will see that its best path will become via 4.2. Yes, that is. So now trace route 20.1.1.1. So it is going via MPLS. Now in case if it's F0x0 goes down, MPLS link goes down, you will see that it will start You see 20.1.1. It must go via backdoor link now, right? Immediately. Yes, it is going via backdoor link. In case if this F0 by 0 comes back up, you will see that once again its best path will be via MPLS domain. You see? So this is the advantage of configuring sham link in OSP. Right? So this is the way to configure sham link, and this is the advantage of configuring sham link. Fine. And even you can look at the database table of Yahoo C1 Show OSP database. You can check it out that it is having now router list of all 4 routers, because in this area how many routers are participating? 4. You can see P1, P2 and Yahoo C1, Yahoo C2, and it is having now router LSA of all those 4 routers. That's fine. Understood? So it is having all 4 router LSAs. Type of LSAs are also there, but that is for those prefixes 100, 100, 100, 200, 200, 200, 200, right? This is for them, it is having type of LSA, right? Apart from that, this is that how can we configure the sham link in OS in MPLS. This is all about that, layer 3 VPN, right? It was all about layer 3 VPN. And right now if you trace route, then it is showing you MPLS labels, right? If someone asks you that, okay, your core network must be hidden, right? What will you do? You will disable TTL propagation. So move on P1 and then say MPLS IP propagate TTL. Say no. Do show history. Just configure this command on all devices now. Similarly on P2, right? Move on Yahoo C1 and once again try to trace route back. You see 3.2, 4.2. 3.2 is this when it is entering an MPLS domain, and 4.2 when it is exiting this MPLS domain. So you have hidden your entire MPLS domain now. Right? Yes. Exactly. In virtual link it shows you VL, right? In as sham link it will show you SL. Try to escape neighbor. Check it out. Of course there must be, but I don't know about that. You can search about that, you can open that packet and you can see that.
So this is useful if an organization wants to run OSP or something end-to-end.
Exactly. Fine. Now in layer 3 MPLS we are having so many disadvantages. Layer 3 VPNs. Very first disadvantage is what? Customer has to configure routing protocol as per the provider. If provider is saying that okay configure BGP, then customer has to configure BGP. If provider is saying, whatever you will be configuring at the end of P, same protocol you have to configure at the end of C. Now P configure BGP, but your device doesn't support BGP. You are having simply layer 3 switch, that is 3750, that does not support BGP. What will you do now? You can't do anything, right? And one more thing, that your routing table is shared with provider. Your routing table is also shared with provider. Provider can look at your routes, can look at your prefixes, right? And what if in case, let's say this is my network, this is one of the branch 1 and this is my branch 2, and I'm using same prefix, same lane, local area network 1.0, and here also I'm using 192.168.1.0, right? I decided range from 1 to 100, and here from 101 to 254 I'm using over here, right? And I want that they must be able to communicate with each other, right? So for that purpose, what can we say? This is your MPLS domain, and we can have a layer 2 connection. Layer 2, we can configure layer 2 VPN. Now it is layer 2, right? Which means that this switch will think that okay, it is directly connected with this switch. It will be simply layer 2, right? And you know, like if you are having same segments on both ends, then also they can communicate with each other without configure any routing protocol, right? And also your routes, your prefix will not be shared with service provider, and also you will not require to configure any routing protocol in between P and C. So there are so many advantages of configuring layer 2 VPN over layer 3 VPN. The only thing, if you are taking connection from MPLS provider as a layer 2, I mean if you are configured layer 2 VPN, right, you can't get internet connectivity. That's the problem with that. But if we are having a separate provider for internet, then we can use it. Because in case if you are having layer 3 VPN, along with that you can also get an internet, right? You can also get an internet along with end-to-end reachability. Like for an example, I want to take internet connection in headquarters of Microsoft, right? So what can we do? We could do one thing on P1 itself, like IP route inside the VRF, right? Inside the VRF, which one? Micro, that is what? 0000, right? And that's next hop address is, let's say 1.1.1, and or you say loop back 1, and the next hop address is what? That's it. Now we have configured a default route that is pointing to the global routing table of P1 itself, and this default route will be part of VRF micro only. So IP route VRF micro. Check it out. This default route must be there. And then what can you do? In RIP you can redistribute it, right? Like router RIP address family IPv4 VRF is what? Micro. And then say redistribute static, and the metric is what? 1. Now you must be able to get this default route onto Microsoft C1. Microsoft C1. Sorry. So IP route. Yes. And from here you can distribute this default route among all sites, right? And you will be providing a single public IP to your customer, right?
On
And
C2 also we have the default route.
no, you don't need to have. I mean, on C2 you can get it with the help from RIP itself. From RIP itself, you can get that. Don't worry about that. You just need to do one thing. You just need to redistribute this static default route, right? You just need to put this static default route, or you see that we configured this static default route into VRF. We configured it, right? Even we could ask to this New York user to configure a static default route towards P1 as well, right? Or we have already redistributed it into RIP. Along with that, do one thing, redistribute it into BGP as well for that VRF on this P1 itself. Like do one thing, router BGP 100 address family IPv4 VRF is what? Sorry, that is micro, and then say redistribute static. Now you will get it automatically in the routing table of Yahoo C2. Sorry, Microsoft C2. Show IP route. Check it out. What's that? Okay, because you cannot redistribute default route or automatically into BGP. So for that purpose, you have to configure one another command over here. Router BGP, that is 100 address family IPv4 VRF, and that is what? Micro. And here you have to say default information origin. Right now you will see that it will be there. Yes, it has received that now. So many things are there to do. So many things are there as per the requirement. I know that some of the people would be blank now that okay, what is going on and all these things, but you know, these things will come to you with time. right? So this is that how can we propagate this default route. Apart from that, what should we do now?
Layer 2
What, layer to VPN?
we started that, right?
Yes, I was thinking about that. So of course, layer 2 VPN would be too much beneficiary over this layer 3 VPN, right? Because you don't need to specify subnets like subnet must match and all these things, right? Nothing. Even PE also will not required to do so many things, right? Even like only MPLS will be required over there. Even MPBGP will also not be required. Right now you are running MPBGP, right, over the service provider. So if you configure layer 2 VPN, then there will not be any requirement of having MPBGP as well, right? So I'll be configuring it in next class now, and for today it is, I think, sufficient from MPLS, right? Tomorrow I'll be taking your class, and probably tomorrow will be your last class or day after tomorrow. Let's see.
सर एक बार सैम लिंक का कॉन्सेप्ट दोबारा बता।
क्या ऐसे समझ लो ना यार, देखो हो क्या रहा था यहाँ पे।